All right, so now, guys, we are going to look at questions, examples 5 and example 6. It says use the fundamental identities to determine if each expression is true or false. And if the statement is false, provide a counter example. So this is important. I don't want you guys to simply stop at true or false. If it is false, explain to me why it's false. Show me the evidence, okay? So let's look at example 5. So we want to use the identities, and there's some up there at the top. So I may want to focus on those Pythagorean identities and those reciprocal and quotient identities. So we want to simplify this, and the question here, is it true that cosecant squared times tan squared times sine, or not tan squared, but just tan, times sine times cosine, is that equal to 1? Well, what I would want to do, my game plan here, is because I have sine and cosine, what my game plan should be is to change that cosecant and tan and rewrite those in terms of sine and cosine. So we know that cosecant is the same thing as 1 over sine, but because that's cosecant squared, we're going to have 1 over sine squared theta, all right? And then tan, maybe I should color coordinate this, so that's in red. Then here in green, tan, we know that tan can be rewritten as sine theta divided by cosine theta. And then sine and cosine is there. I'm just going to rewrite that in black. I'm not changing anything. I'm just going to leave that just the way it is. And I'm going to put a question mark. Is that equal to 1? Well, let's see what happens. What I have here is, let's change this. I know that this cosine could possibly cancel out that cosine. And what you notice is that I have 2 sines in my numerator. Let's highlight this. I have 2 sines in my numerator, sine thetas. If I multiply those together, imagine multiplying those together, that would give me sine squared theta, okay? And in my denominator, I have a sine squared theta. So if I pick a different color, let's just say yellow, then I know that that sine squared theta is going to reduce those 2 sine squared thetas. And because everything reduces, what I'm left with here is that 1 is equal to 1. So that is a true statement. That works. Well, let's come over here to the left. Again, I have tan times cosine. And I want to know, is that equal to 1 minus cosine theta? And my rule or my suggestion is if we have tan, we should rewrite that using, sine and cosine. So when I see that tan there, I would immediately rewrite this as sine theta over cosine theta times cosine theta. And so I'm asking myself, is that equal to 1 minus cosine theta? Well, immediately I can see that things reduce. I have that cosine and cosine there. Those are going to reduce. And what that leaves me with is that sine theta is equal to 1 minus cosine theta. And so that's not true. If we look at our identities, I don't have an identity that says that sine theta is equal to 1 minus cosine theta. What I do have is an identity that says that sine squared theta is equal to 1 minus cosine squared theta, but that is not the same thing. So that doesn't work. One way that we can prove that that is not the same, let's say that we want to actually show it numerically that what I have there is not the same. What we could do is look at those values. I can't show the values, but I am pretty sure we have it on our notes. Give me a second to look at our notes. On the page before, if you print out your notes, you have a trig function values, trigonometric function values of special angles. There's a table there with some values in it, values from the unit circle. So what we could do is we could pick a value from our unit circle or from that table. Let me put a line here so I can separate this. I could choose to let theta be equal to pi over 6. And just just so you guys know where exactly I'm at, I'm looking at this table here. And so I just chose to look at pi over 6. I'm going to look at all of these values here. These are the values I'm going to use, okay? So I'm going to let pi over 6 be theta. And so we're going to say that if that is true, then let's pull out the value for sine theta. So sine theta, so sine of pi over 6 is that 1/2. So if I come back, I can substitute that, and I can say that 1/2, I want to know, is that equal to 1 minus, and let's find cosine theta. And again, we're letting theta be equal to pi over 6. So if I let theta be equal to pi over 6, I'm looking for cosine. That's the square root of 3 over 2. So 1 minus the square root of 3 over 2. I can stop there because what I know some of us, we kind of sometimes have trouble adding and subtracting fractions, but what I know is that 1/2 is a rational number. Square root of 3 over 2 is an irrational number. There's no way that these values are going to be equal to one another. So if you look at it this way, again, I can say that those two values are not equal to one another. So this is a false statement. And I have proven right here using values from our unit circle that that sine theta is not equal to 1 minus cosine theta.